Okay, we're still in 16.8, but we're doing a little section at the end of 16.8 called an atomic description of dielectrics. So let's get to the PowerPoint. And the reason uh, dielectrics work is because of a concept called polarization. And here is an example of polarization. Water molecules have a covalent bond, so the oxygen uh, it has two extra electrons in it that it's borrowing from the hydrogen. So the hydrogen is the hydrogen atoms that have positive are positive because they're sharing their electrons with the uh, oxygen atom, and the oxygen atom is overall negative because it's got its shell's full, and so it polarizes the water molecule. This concept is used in NMR. If you're familiar with it, nuclear magnetic resonance, you put uh, the magnetic field on, and the polarized water molecules begin to precess. You hit them with uh, uh, electric a pulse that changes the orientation and the way they come back. Tells you how the water is bound to the material. It tells you the amount of moisture in the material and how it's bound to the molecules uh, in the materials. So anyway, the water molecules are polarized, and this polarization is what causes dielectrics to work. As a matter of fact, the water has a high dielectric of about 80. If you look at well, let's just go back and look at if you look at water, it has a dielectric constant of 80. It doesn't give its breakdown voltage, but you can see other than strontium titanate, uh, it's quite a bit. Uh, the dielectric constant is much greater than all of the others except strontium titanate. So let's go back here. So this polarization is what causes the dielectric. So if we have a symmetric uh, molecule, um, you can see that if there's no electric field, it's neutral. It's balanced. But if you put an electric field here, there's an electric field in B. There's an electric field coming from the left, and that pushes the negative uh, negative portion to the right, making the overall positive portion to one side and the negative portion to the other side. So it polarizes. It's induced polarization from the electric field. So this induced polarization is what happens. You can see here there's a dielectric. Just in A, there's just a dielectric. Polar molecules are randomly oriented in the absence of an external field. When an external field is applied, the molecules partially align with the field. So the charged edges create an induced electric field. You can see the E induced and pointing in the direction opposite E sub 0. Well, that's what lowers the voltage. We saw in the previous example, you put the dielectric, it went from 2 volts to 1 volt. It's that E induced. You can see that uh, the all of those positive are inducing an electric field in the opposite direction that the E0 is. So that lowers the voltage. If you were to increase the voltage, you would push some more electrons off the positive plate and bring it to the negative plate, and that increased. You can for the same voltage, you can get more charge on your capacitor, um, and I think that's about it for some for that section. The rest of it is a topic summary. I'll provide. I'm not going to discuss the topic summary, but I will provide those on the quiz page. And I think that's I've covered everything I need to on this section. This again, this is 16.8. 16.8.1, an atomic description of dielectric. Okay.